To estimate the integral from x equals 1 to x equals 2 of e to the negative x squared dx using n equals 4, we would divide the interval a comma b, which is 1 comma 2, into 4 subintervals. Each of the subinterval has a width of delta x equals b minus a over n. b is 2, a is 1, and n is 4. This is 1 over 4, or a quarter, 0.25. Each of the increment has a length of 1/4. Thus, x sub 0 is always a. Lower limit of integration, x sub 1 is a plus 1 delta x, which is 1 plus 1/4, 5/4. X sub 2 is a plus 2 delta x. This is 1 plus 2 over 4, so that is 6 over 4. X sub 3 is 7 over 4, and x sub 4 is 8 over 4, but 8 over 4 is 2. X sub 4 should be the last x value in this interval. On this number line, we start with x sub 0, then x sub 1, x sub 2, x sub 3, x sub 4. 4 intervals. We then use either the left sum, the right sum, or the midpoint rule to estimate the area under the curve above the x-axis from 1 to 2. N is the number of intervals, so in this case, the left sum would be L4, the right sum would be R4, and the midpoint would be M4. By the left sum, we mean to use the left endpoint of each of the subinterval to determine the height of the rectangle. Thus, from 1 to 5 over 4, we use the left endpoint 1, go up to the graph to obtain the height. We use that height to draw the rectangle. In the second interval, we use the left endpoint 5 over 4, go up to the graph, and use that height to draw the rectangle. From 6 over 4 to 7 over 4, we use the left endpoint, come up to the graph to get the height, then we draw a rectangle using that height along with the width delta x. And from 7 over 4 to 8 over 4, we use the left endpoint to determine the height of the rectangle. Thus, the height is determined by the left endpoint 1, 5/4, 6/4, 7/4. That's it. 4 left endpoints. When x equals 1, f of x is e to the negative x squared, because the function f of x is e to the negative x squared. It tells us how height the functional value is. When x is 5 over 4, the height is e to the negative 5 over 4 squared, e to the negative 6 over 4 squared, e to the negative 7 over 4 squared. The total area is approximated by 4 of these areas, A1 plus A2 plus A3 plus A4, where A1 is the height e to the negative 1 squared times the width, which is delta x, but delta x is 1 over 4. The second rectangle has an area of height e to the negative 5 over 4 squared times the width 1/4. The next rectangle has an area of e to the negative 6 over 4 squared, that is the height, times the width 1 over 4. Plus A4 is e to the negative 7 over 4 squared times delta x 1 over 4. Oftentimes, we factor out the delta x and we just simply add the height, e to the negative 1 plus e to the negative 5 over 4 squared plus e to the negative 3 over 2 squared plus e to the negative 7 over 4 squared. Notice that there is no need to simplify the fraction because we will use a calculator to obtain a numerical value for this expression. This will be 0.182415, round to 6 decimal places. This is the left sum estimate for the integral from x equal 1 to x equal 2 of e to the negative x squared dx using 4 rectangles with the left endpoints. Using the right sum R4 to estimate the integral, for each of the interval, we would use the right endpoint to obtain the height of the rectangle. From 1 to 5 over 4, we would use x equals 5 over 4, go up to the graph to obtain the height of the rectangle. This time, to draw a rectangle, we would go to the left. For the next interval, we would use the right endpoint 6 over 4, go to the graph to obtain the height of the rectangle. For the interval 5, 4 to 6, 4. Next, we use 7 over 4 for the right endpoint of the interval 6, 4 to 7, 4 to obtain the height of the rectangle. For r equal 4, we should end up with 4 rectangles. The right endpoints that we need are 5 over 4, 6 over 4, 7 over 4, and 8 over 4. But 6 over 4 is 3/2, 8 over 4 is 2. The heights are e to the negative 5 over 4 squared, e to the negative 3 over 2 squared, e to the negative 7 over 4 squared, e to the negative 2 squared. We then add up the areas of each of these, where the area is the height times the width, but since we have the same width, we factor out the width just like we did earlier. We factor out the width so that we can add the height inside the bracket. E to the negative 5 over 4 squared plus e to the negative 3 over 2 squared plus e to the negative 7 over 4 squared plus e to the negative 2 squared. Notice that even though we add the heights, but these heights multiply the width, that's why we would end up with the area. This would give us approximately 0.09502, rounded to 4 decimal places. Using the left endpoint, we see that the functions are decreasing. Therefore, we end up with an overestimate. These are the error. Using the right endpoint, the rectangles are below the curve, and we did not include these regions, so we would end up with an underestimate. So the exact value for this integral is somewhere between 0.095024 and 0.182415. We don't know what it is, but since one is an underestimate and one is an overestimate, we are pretty sure that the exact answer is between the two.